Hello everyone, in this video tutorial we will be solving our Donald Neamen book problem 3.32. We are asked to find the probability that an energy level is occupied by electron if the state is above the Fermi level by kT, 5 kT and 10 kT. Okay, for this we need the Fermi-Dirac distribution function, which is given as 1 over exponential E minus EF the whole divided by kT. Okay, this is our formula for the probability distribution. Okay, Fermi-Dirac distribution. Okay, so we will be substituting E minus EF is equal to kT. Okay, for the first case, E minus EF equal to kT. So this becomes 1 over 1 plus exponential kT by kT, right? So it will become 1 over 1 plus E. So if you simplify this in the calculator, you will get 0.269. Now we will take B part. Here E minus EF is equal to 5 kT. So again the same formula. Okay, 5 kT by kT. So it will become 1 upon 1 plus e raised to 5, and this will become the probability that energy level is occupied above 5 kT is 6.69 into 10 raised to minus 3. In the C case, where it is 10 kT, it will be like this: f of fe is equal to 1 over 1 plus e raised to 10. And if you simplify this, you will get the value which is equal to 4.54 into 10 raised to minus 5. This is the probability to find the electron if the state is above the Fermi level by kT by 5 kT by 10 kT.